Today in regular chemistry, we're going to finish up chapter 4, and I'm going to show you how they come up with this number, this average atomic mass number that you see at the bottom of each of the element block. Okay, you're going to need your calculator. Okay, so the isotope that they used when they're coming up with the average atomic masses for all of these elements is the carbon-12 isotope. Okay, and it is the standard for atomic weights. It is assigned a mass of exactly 12 atomic mass units, or AMUs, and they compare all of the other elements to it. Average atomic mass, or average atomic weight, is the average of the atomic masses of the isotopes of an element. It depends upon two things. It depends upon the mass and the abundance of each isotope. To find it, you will multiply the mass of each isotope by its abundance, and then the resulting products are then added, and the sum is divided by the total abundance. So we're always going to assume that we have 100 particles. So here's an example. So neon has two isotopes. Neon-20 has an actual mass of 19.992 AMUs, and neon-22 has a mass of 21.99 AMU. In an average sample of 100 neon atoms, 90 of them will have this mass, and 10 of them will have this mass. Calculate the average atomic mass. So we're simply going to say neon average atomic mass, or you can put AMU here, is equal to, so we have 90 times this mass, the neon-20 mass, 19.992, put that in parentheses, plus we have 10 more of them that have a mass of neon-22, so that's 21.999. Okay, we're assuming we have 100 particles, so we're going to divide this by 100. So you will always divide by 100. I think it's simplest if you will do the math and write it above each one of these and then add them up and divide by 100. Or you can put this all in parentheses, you know, this in parentheses and then this in parentheses. Okay, so you take 90 times 19.992 equals, so this is 1,799.28, and then 10 times 21.999 is equal to 219.99. So I'm going to add these two numbers up. So I'm going to just leave this in the calculator. So hit plus 1799.28 equals, and then divide by 100. So we get 20, and let's just do this to two decimal places, 20.19 AMU. Always check to make sure this number falls between your lowest weight and your highest weight. If it is outside that range, then you have done something wrong. It could have 3 isotopes, it could have 4, it could have 5. You would just put each of them in parentheses and then add them all up and divide by 100. Okay? Now our last topic is we're just going to introduce nuclear chemistry to you. Just the very basics. Nuclear chemistry, or nuclear reactions, are different from chemical reactions in that in a nuclear reaction, you can actually, the atom or the element will actually become something else to become more stable. In a normal chemical reaction, you do not destroy or create new elements in a chemical reaction. So if the nucleus of an atom is unstable, and that's typically because you have too many or too few neutrons compared to protons, it can emit radiation or radioactivity or radioactive decay to become more stable. In doing so, it will change into another element that is more stable. Now, there are two things that are conserved in chemical reactions. In nuclear reactions, you will have mass conserved and charge. So mass and charge are conserved. So there are 3 types that we're going to talk about. The first one is called alpha radiation. Alpha radiation will emit alpha particles. An alpha particle will contain 2 protons and 2 neutrons, and so it has a charge of 2 positive since it has 2 protons. You can write that as the Greek letter alpha, but that doesn't tell you anything. So it's a lot easier if you will write an alpha particle as a helium, He42. Okay, so let's do a practice problem. So let's say we have uranium-242, and I tell you it's going to undergo alpha radiation. So you need your periodic table, and you look up uranium's atomic number, which is 92. So that goes here, 92. I should have put that up a little bit higher. Equals, and so it's going to undergo alpha radiation, so I had to tell you that. So I'd go ahead and write down what my alpha particle represents, helium-42, plus, now we want this side of the equation, this side to equal. So our masses have to equal, so 242 minus 4 would be a mass of 238. And then 90 plus 2 would equal 92, so then you look up the element 90, and you see that is thorium-TH. So if uranium-242 underwent alpha radiation, it would actually become thorium, and it would emit an alpha particle along with it. The next type is called beta radiation. And beta radiation will emit a beta particle or a fast-moving electron. You can write that with the Greek letter beta, which is a B with a long tail, or, electron has 0 mass and a charge of -1. So it's better to use this so you can see what's going on. So let's take our uranium-242, and let's say this time it's going to undergo beta radiation instead of alpha. So I have to tell you which one. So uranium-242, we already know its atomic number is 92. So we know it's going to undergo beta radiation this time. So we're going to put this in here. So that's your beta particle, electron 0 -1 plus. Now we have to figure out what it becomes. So here's where you have to be careful. So you want your right side of your equation to equal your left, so your mass is not going to change. So it's still 242. So we want it to equal 92. So you wouldn't say 91 because 91 minus 1 would not be 92, but you would say 93 because 93 minus 1 would be 92. Then you look up element 93, and that would be neptunium, so that would be Np. So in this instance, uranium-242 would become this. Our last type is called gamma radiation, and it will emit a gamma ray, which is a high energy ray that possesses no mass or charge, so it's massless and it doesn't have a charge, and it's written as the Greek letter gamma. It occurs along with beta and alpha. So you wouldn't usually just have gamma by itself. So we could take either one of these. We could say it undergoes gamma and alpha. If we said it underwent gamma and alpha, it would be this. If we said it underwent gamma and beta, it would be this. Or we could choose some other element. So that finishes up for this chapter. And so now you can finish your study guide. So for today's lesson, it is questions 21 through 28. Thank you.